Hello guys, welcome to CADMAT. This is our class 12 part 3. So in this class we are going to see the remaining portions that are left in class 12 part 2. So we are going to try to complete this remaining portion in this section. So in this coming to the first topic, first let's go to the assembly design workbench. You can directly click here or you can go to start mechanical design assembly design. So currently we are in the assembly design workbench. So before getting into this, we just take one example. Okay, finally created this screw now. So let's click on this. We're moving to this assembly again. So if you see here, if you see, I just clicked on this product. So that if you see the constraints are not being highlighted. So whereas if I click on the sub-assembly, you can see just this all the constraints are getting highlighted. So you can use this constraints in this some sub-assembly. So whereas the product, so this is like a single part. So this is sub-assembly is like a single uh, component in the whole product. Whereas in this sub-assembly, there's still you can keep some sub parts here for completion of the sub-assembly. So to assemble these sub parts in the sub-assembly, you need to click on the sub-assembly so that the constraints will be highlighted, showing us that you can use these constraints for assembling these parts in the sub-assembly. So what I am going to use is, if you go for this quick constraint here, so clicking the quick constraint and selecting these two bodies, the constraint is generated automatically, the surface contact constraint. So we just select the center axis to this and this to this, and the constraint created as a coincidence constraint. So you don't need to select the individual constraints here. So we just need to select the constraint you want by selecting. If I select the two faces for this and this, it will automatically understands that the possibility is a contact constraint. So I'm selecting the center axis of this and this hole. So in the same way it understands the constraint mostly is a coincidence constraint. So if I just click like update, like control U, if I click on the control U, it got updated. So by taking the two constraints into consideration, this is the final position that the screw is placed. So I just want to remove this contact constraint here, and I want an offset constraint for this contact, the same surface contact but the different face, the bottom face of the screw. So let's see how gonna affect on the model. So this is what happened. So perfectly fitted into it. So just adding these two, and now this is how the quick constraint works. So coming to the next one is a reuse pattern. Here is a reuse pattern, and don't you think that I missed this too? Yeah, I will be coming back. So before the discussing these two, we'll complete some of the important uh, options here. So, so coming to this reuse pattern, uh, select this one. So it is asking for keep link with the pattern. So this is to select this one. Okay, then generated component push with respect to patterns definition. Okay, mm, then let's select the one that's selecting these holes here. So by selecting those holes that are created earlier by using the circular pattern, so it will take automatically the circular pattern by selecting one of the patterned holes. So these are the two different constraints that are applied to the main sub-assembly between the two parts of a sub-assembly. So we can just apply, click OK. So you can see the individual accesses. So individual planes have been created for each part 2. So here then you can see in the sub the tree itself, you can see in the sub-assembly there are different parts have been created for each one. You can select each one individually. Again, go back to the sub-assembly. So this is one type of reuse pattern, and let's so here you can see the assembly features. So reuse circular pattern. Okay, let's undo this. Now again, go to this circular reuse pattern and component to instantiate is part 2, and instead of this reuse pattern, create a new instance. So what it makes is that user reuse the original component. So this option is it will use it to retain the original components at its location and generate the instances and populate only the vacant locations. So if you go for the create a new instance, so this option is used to place the new instance of the component on all the patterned instances, including the original instance. As a result, there will be two overlapping instances at the location of the original component. So, so creating a new instance, component to instantiate is this, and pattern as this, and to see the create a new instance, click apply. Okay, minimize it. So in the constraints, so here if you uh, try to hide this one, so or hide the main part, so this is again pattern part overlapping with the main part. So that is the reason why even if I hide this part, I can able to see the screw here. So if I hide this one, uh, total all the parts are getting hidden. So let's undo this one. So this is creating a new instance, and coming to the last one, cut and paste the original component. So let's see this one now. So let's undo this again, and use pattern and cut and paste the original component. So component to instantiate is this, and pattern is this. So just click apply and click OK. So here you can observe the difference here. So the cut and paste the original component means, so he's used to remove the original components from its location and place the new instance of the component at all locations. The difference is very clear. So in the reuse the original component, we'll be reusing the original component at its position without creating a new one at that particular position. That means here. So whereas this in create a new instance, we'll be creating the same pattern, but the new instance will also be created overlapping the already existing instance. That is the main instance. So in that case, we will be having two instances. One is the original and one is a pattern instance at a single position. So coming to this cut and paste the original component. So in this, the original component will be removed and the new component will be pasted at that main position here. So the overall pattern will be created, so by cutting the original component and again pasting a new. So that is how it works. So let's try by generated constraints and do this one again. So reuse pattern and select the generated constraints instead of pattern constraints. So selecting, keeping it in reuse the original component and component to instantiate as this and the pattern as this. Click OK. So here you can see the constraints are created for each one individually. So that's the reason in the constraints you can see number of constraints repeated. for each screw head here. So undo it. Whereas in this, in pattern definition, it will consider the pattern and it won't be considering the constraints. It will be considering only the what are the command that is given in the pattern definition. That's the reason you can't be able to, you're not able to find the number of constraints here. Only the main constraint will be given here for the main part. So in this, you can see the keep link with the pattern is highlighted. So if you remove this and selecting the component to instantiate and the pattern this, then we select keep link with pattern. You can see there is no options are created here. We are not able to even select this constraints here. So if you remove this, so we can see these are the main constraints for applied for the main screw head and the whole other part here. So if you want to reuse these constraints, so which one you want to reuse, you can control and press select constraints, and you can select all and apply it. So this is what happened, same as that generated constraints. So just close this, and so as soon as you remove this keep link with the pattern, it is automatically shifted to the generated constraints from pattern definition. So the constraints are created for individual parts separately. So if you keep it in the keep link with the pattern, so the constraints will remain same and the pattern will be created without creating the individual constraints. So the main priority is given for the pattern definition. The pattern definition follows the pattern that you used for creating the holes here earlier. The pattern that you used for creating the holes here for this component, so the same pattern definition is applied to this screw head or the screw to follow the same pattern that applied to the hole, so that it won't be considering the constraints here. So that's the reason why the constraints are limited in this case, and main priority is given to the pattern definition that you followed for creating these holes and reusing that same pattern. That's the reason the name itself is showing the reuse pattern. So that's the reason you can just by keeping on this pattern definition, we'll be using the same pattern that was used to create these holes, and giving the main importance to the pattern, and by neglecting, you can say that neglecting the constraints a little bit. And that's it guys for this reuse pattern. So I think by this I'd like to end this section. I thought of completing this section with this, but unfortunately it is taking much time for explaining each and everything clearly. So anyway, we'll see in a remaining part in the next section. So the main concept is to get a clear understanding. It's not a matter of time or a number of sections. So I hope you will enjoy the class, and I'm waiting for the next section. We'll see the remaining part, remaining options here. So until then, have a good day. Bye bye.